Okay, these problems here. Let's see. So this is just simple indefinite integral. So let's see. Antiderivative cosine is sine of x and of h plus c. Okay. Excuse me. Fundamental theorem of calculus. So let's do the antiderivative here. That'd be 1/2 x squared plus 1/6 x to the 6th. And then we're going to plug in 3 zeros. So this gives us 1/2. That'd be 9. So I'll just write 9/2 plus, let's see, what is that? 3 to the 6th. 729. 729 over 6. And that'll go to 0. So that's kind of nice. So really that right there is my answer. I'm just gonna go ahead and see what that would be though. So let's see. 9 divided by 2 plus 729 divided by 6. It's 126. Okay. Done that well. Nicely. Oh, and we can just check that this whole problem in the calculator too, since it is a definite integral. So 0 to 3 of x plus x to the 5th dx 126. Yep. Let me check that. Area, 2 graphs. Let me throw it in the calculator here, see what this looks like. X squared and 2 over x and y equals 0. And x equals 5. So I'm just looking at my calculator. Kind of looks like this. So it's a little tricky here because it's top minus bottom, but there's 2 different chunks. So we'll just split it up into different areas. Let's see. So for this chunk right here, I'm just looking at my graph on Desmos here. That would be, the top is the 0.5x squared minus 0, because it's just, this is on the axis. And that's from 0 to 1.587. So I got this. From 0 to 1.587 it's just 0.5x squared. It's the area under that curve. Okay, but then from then from 1.587 up to x equals 5. Now the top is that black line, which is 2 over x. And that's it, because there's no bottom there outside of the axis, so it's just from the area, like right here under the axes. Excuse me. So and then you're just adding these 2 things together. So we could just put all this up here. Well, I won't do that. I'll just put the plus over here. There we go. And I'm just going to go ahead and type those in. Okay, so assuming I typed everything correctly, I got 2.961. Okay. Let's keep going. All right. As always, I'm going to graph this to help you get an idea of what method I need to use. So this is 1 over x, 2 over x equals 1, x equals 3. Okay, so we recognize this shape from the last one. Find the volume when rotating around the y-axis. I changed this, I think. Oh, it's fine. Around the y-axis. Okay. So this one will just be a shell with vertical slices. And again, that's just looking at the picture here. Because I'm going around the y-axis, right? Yeah. So let's see, it'd be from 1 to 4, no, 1 to 3. It's 2 pi, and the radius is just the distance from the y-axis to any of the slices, which for this would just be x. That's the x distance. And then the height is going to be the top one minus bottom, which would be 2 over x minus 1 over x. Because again, so shell is just 2 pi r times the height. and r is x, and the height is this distance right here. Cool. Let's just see what that gives us. 1 to 3 of 2 pi x. About 12.566. Excuse me. No, go ahead. Okay, line x equals 4. All right, so now this becomes it's like a washer problem, except that you'd have to do multiple just because of the way its shape is, and the way that the right and left things change. What's on the right and left, you have to do multiple integrals if you're going to do a washer. So I'm just going to do shell again. The only difference, because the height's still going to be what I had up here, so that's kind of convenient. I'm still doing 1 to 3. 2 pi. This is the tricky part. The radius. I'm asking from the line y equals x, x equals 4. So again, here's kind of a picture. But I'm going around this line right here at x equals 4. Okay, so here's like one shell right there. Okay, so that's like one shell. It's distance, so like the radius right here. That's what I'm looking at. Well, I could get that from 4 as the distance from that line back to the axes. X is this distance right here. So 4 minus this distance leaves me with what I want, that distance right there. So let's see, the radius would be 4 minus the x value. And then the same height as before. 2 over x minus 1 over x. It's the top minus bottom, dx. So let me just make that change on my last problem. So it's 4 minus. I get about 15,044. Okay, from the volume of each of the following shapes. Okay, so let's throw this in the graph. Okay, x equals y squared, and x equals negative y squared plus 3. All right, so we're probably using horizontal slices based on how this is given. And well, this they give you that perpendicular to the y-axis, so you're talking horizontal slices. Let's see, rectangles where the height is double the length of the base. So that's just base times height. I'm looking at my y values now. They're they're not that bad. So let's see, my y values go from negative 1.225, negative 1.225 up to positive 1.225. Let's see, the base is the right minus the left. That is the black one, so that is negative y squared plus 3 minus the y squared. Okay, so that is the, I can just go ahead and take the, so that's the base of that, of one slice. It kind of looks like this, right? So like one slice right here, its base, that distance is negative y squared plus 3 minus y squared. And we can just go ahead and make that, so what, minus 2y squared plus 3. Okay, now a square we would have, if it were a square area, we would just, oh, I guess that's the next problem. We'll do that in a second. But this one, the height is double the length of the base. So this is b, and then h is 2b, double the length of the base. So I would put 2 times all this stuff again. And so that's the base, and that's the height. B times h. dy. Okay. It's going to be negative 2y squared plus 3, 2, and negative 2y squared plus 3 dy. Okay, becomes about 23.515. All right, now squares. Okay, so that's convenient. It's just going to be the same exact thing, except this time you're just going to take that base and square it. That's all that is. So I'm going to copy this last one, paste it, and then delete this. Oops. Squared. And that's about 757. What am I going to need? All right, and last one. Isosceles triangle where the base is hypotenuse. Okay, this is kind of annoying. It's a little bit more complicated. Let's see it. Still got that. So I'm going to look real quick at. Okay, sorry about that. I had a little break there. Yeah, these were isosceles triangle, and I as I've told you all, it's supposed to be right triangle. Yeah, isosceles right triangle where the base is hypotenuse. Okay, so a couple things we need to do here. Sorry, let me get this graph up that had for this. Okay, this was x equals y squared, and x equals y squared plus negative y squared plus 3. Okay. All right, so same as always, I just need the area of that one slice. So like there's one slice, here's like another slice, the hypotenuse being that. So I'm just gonna Google, so what's the area of a right isosceles triangle? Okay. And keeping in mind that we know the base. Well, it's that same one we've been using. What is that? So the base is this. Like that's the length. That's this distance right here. Well, if you look at an isosceles triangle, I'm going to kind of flip it in my head a little bit here. I'm going to make it so that it looks like this. So there you go, that this hypotenuse, that distance right there is the negative 2y squared plus 3. And then this is just, and these two are the same. I'll just call them S. Those are the side lengths, right? Okay, well, it's still going to be 1/2 base times height, except here, base and height are both S. Okay, so that just means it's S squared divided by 2, or 1/2 times S squared. All right, now this is the tricky part. What is the excuse me, connection between this length and these lengths? If you look at an isosceles triangle, if those are, well, let's call these S again. S, then the hypotenuse is S times the square root of 2. And that's always the case. That's always the case. So what I'm claiming is that negative 2y squared plus 3 equals S times square root of 2. And you need S to figure out S squared over 2. So we'll just divide that by square root of 2. And now I've got S. That's it. So then let's put it all together. Negative 1.225 of, go away. It's just S squared over 2, but I need to put in what my S is, so negative 2y squared plus 3 all over square root of 2 squared. And let's be clear that, there, that's a little better. That's all of that is S squared divided by 2 dy. And that's it. Yeah, get back here. Throw that in the calculator, see what I get. Oops, this is only 225. Let's get 2 of negative 2y squared plus 3 and all of that. So I need, this is very careful. I have to make sure that I put the dividing sign inside that. So square root of 2. square root of 2. Yeah, square root of 2, exponent 2, and then the bottom is another 2. That is kind of ugly looking dy. About 2.93. Cool. Now again, I wouldn't expect you to memorize these things right here. I looked those up, or about the relationship around isosceles triangles. That's fine. Look that up. You don't need to have that on hand. You should be able to know where to go to find the tools. So just Google them. Okay, let's see this next one here. Okay, I'm going to graph this x minus 2 squared. Oops. Plus y minus 4 squared equals 9. Yep, circle. Rotate around y equals -2. Okay, so generally it kind of looks like this. And I'm rotating around the center. Okay, I'm going to do washer, and that would be vertical slices like that. Oh crap! Oh, the whole circle went away. Oh no! Like this. Okay. So washer, vertical slices, and that's nice. Okay. Well, I got some sulfur anyways. Okay. All right. Let's first get the equations for the circle cut up so that I have an inner and outer. So since I'm going this way, I need to cut it up like this so that I have here's the outer, and then here's the inner. So it means I need to solve for y. So I have the x's. So I have in terms of x. So I'll move this over here. So y minus 4 squared equals 9 minus x minus 2 all squared. Square root both sides. Oops. And then add 4. Now again, when you square root both sides, technically you'll get a plus or minus. So that's our two equations right there. So I've got the outer will be y equals, I think it's going to be the negative one. I'll check in a second here. 9 minus x minus 2 squared plus 4. So if I graph that, 9 minus x, x minus 2 squared plus 4. No, that's going to be that's the inner one. That gives me, this one down here. So the outer one's going to be the top one. Outer, it's going to be y equals the positive 9 minus x minus 2 squared. Okay, for washer, I've got the inner, I've got the outer. That's pretty much it with one thing, that we're not going to an axis here. So let's look carefully. The inner radius, what this right here tells me is this distance from this curve. I'm going to erase all this here. Sorry. Go away. Let's try this again. It gives me this distance right here. Like for my inner, at any moment, it would give me that distance. But it's that plus 2 each time. So my inner is all of this plus another 2. And then the outer is the same thing. It's 2 plus that distance right there. So that is the outer and inner behaving now. So same thing now. Let's go ahead and, from what to what? This is going from, I'm looking at my x's. I'm looking at my x's from -1 to 5. And the outer, it's outer minus inner. Pi r squared. Pi, and then r squared. 9 minus x minus 2 squared plus 6. Okay. Minus, forget squared. It's pi. Now let's do inner. Negative 9 minus x minus 2 squared plus 6 squared dx. I'll pause right. And that gets me to about 1255.9. All right, that one's kind of different for everyone. Language, how or what disk and washer related? Well, washer is just two disks, problems together, and an inner and an outer one. You're basically doing an outer one, subtract with the inner one. There you go. Oh, unwrap or open up a shell slice, that just gets you a rectangular prism. When you unwrap it, it just kind of looks like that. And that's it. And that's why but the base is 2 pi r, because it's the circumference when it's wrapped up as a shell. It's the circumference here. And when you unwrap it, it's just that length right there, and then the height. With your dx or dy being this depth right here. And h is just that length. This one, a couple ways. Okay, it's around the x-axis. It kind of looks like this. Around the x-axis, that's this way. So you could do horizontal slices, giving you shell. I'd give you a shell right there. Okay. Or you could do vertical slices with washer. Yeah, and here's your outer and there your inner right there. Okay, hope this has been helpful.